Hi friends, mistakes are a step in learning. You are not perfect when you start learning. An electric current of 1.6 ampere is passed through an electrolytic cell containing sulfuric acid solution for 7.44 hours. Now, we are asked to calculate the volume of hydrogen gas produced at SDP. Okay, here is a vessel containing sulfuric acid. It seems like this is a strong acid. In water, most of the H to SO for molecules dissociate into H+ ions and sulfate ions. Two electrode units are dipped into it. Both electrodes are connected to a DC voltage source. Sulfuric acid solution is an electrolyte solution, so this system forms a closed electrical circuit. Electrons will flow from the negative pole of the battery to the positive pole of the battery. When passing through the solution, these electrons are captured by H+ ions. H+ ions will be oxidized to hydrogen gas. The oxidation number of hydrogen decreases from +1 to 0. This is a reduction reaction. On the other side of the electrode, there are sulfate ions and water molecules. Since the oxidation number of sulfur and sulfate ions is +6, this value has reached its maximum value. This ion will not undergo oxidation, but water molecules will change into oxygen gas and for H+ ions. The oxidation number of oxygen increases from -2 to 0. This is an oxidation reaction. The H+ ions on this side will move towards the lefty electrode to fill the lack of H+ ions. Thus, bubbles will appear on each electrode. Hydrogen gas bubbles on the left side and oxygen gas bubbles on the right side. The gas bubbles will continue to form as long as the electric current flows. We want to calculate the volume of hydrogen gas, so we will pay attention to the reduction reaction. Pay attention to the equation: 2 moles of electrons form 1 mole of hydrogen gas. To get the value of moles of hydrogen gas, we must know the value of moles of electrons. This equation is quite well known in the electrolysis process. Moles of electrons are equal to IT divided by 96,500. From the problem sheet, the value of the electric current is 1.6 amperes. The time value must be in seconds. Multiply the time value by 3,600. This calculation is quite easy. N is equal to 0.3497 moles of electrons. This number of electrons will form 0.17 hydrogen gas. This is correct. At SDP, 1 mole of gas will occupy a space with a volume of 22.4 liters. Mathematically, the volume of gas at standard conditions is 22.4 times the mole value. We already know the value of moles of gas. V is around 3.9166 liters. This value corresponds to option C. Happy learning, everyone!